A very good morning to one and all present here. Knowledge is power. Knowledge shared is power multiplied. With this quote, myself, T. Abhimala, Assistant Professor, Department of ICE, St. Joseph's College of Engineering, proudly welcomes you all for today's webinar on fire and gas detection for oil, gas, and process industrial applications. About our college, you choose, we do it. With this tagline, our college, which was started in the year 1994, currently excelling in its 26th year. It is NAC accredited with A plus grade with the all-time highest score of 3.46. In NARF ranking, our college holds the 160th position out of 1,071 applied institutions in India. It offers 10 undergraduate and 6 postgraduate courses. About our department, Instrumentation and Control Engineering, one of the renowned department, operates since college inception. It is MBA accredited. The main glimpse of the department is experienced and well-qualified faculties with 50% doctorates, with enhanced lab facilities. Now, it's time to introduce the speaker of today's session, Mr. Satheesh Kumar Veluswamy, an instrumentation and control engineering professional from Coimbatore, Tamil Nadu. He also holds a PG diploma in international business from Laila Institute of Business Administration. He has more than 10 years expertise in the field of oil and gas instrumentation. His key areas are in the field of fire and gas safety, process analyzer systems and instrumentation, hazardous area instrumentation interfaces, and industrial automation. He currently works as an operation manager for INSTROL. INSTROL provides world-class customer service in trading and technical services to Qatar clients in oil, gas, and petrochemical industry. On behalf of the department and our management, I extend my warm welcome to Mr. Satheesh, sir. Welcome you, sir. With no much delay, I'm handing over the session to Mr. Satheesh Kumar. Sir, the session is yours.
Thank you, ma'am, for the wonderful introduction. And I also thank all the attendees to make time for this session. Before I share the screen, can you, ma'am, unmute the other side to be more clear? Hello, good morning, everyone. Ma'am, just to ensure everyone is able to hear, can you get a confirmation so that we can start?
Yes, sir. Yes, sir.
Yeah, so now my screen is visible. I hope, I think it's good to start now. Once again, thank you, ma'am, for the wonderful introduction. And also, I thank the entire organization, St. Joseph College of Engineering, for giving me the wonderful opportunity. I also thank all the faculties behind this to arrange this valuable time and session. And finally, I have to thank all the attendees who make the time during such a difficult time, COVID and challenging situation, to be here. And I'm sure everyone is on the learning appetite. So it's my my commitment, I will try to cover as much as possible, precisely, and also ensuring on time. So to start with, I'll be very precisely covering around 40 slides in 45 minutes. Then last 15 minutes or even 30 minutes, I don't have any issue. I can bear for answering your questions and also sharing any other experiences we may have. So to start with, I understand. I mean, the faculty has already introduced me very well, but just to cover some more points. So other than the domain skills and experience already ma'am has already introduced, so now I'll be touching mainly on my functional skills. I'm mainly on the sales, marketing, and business operations under my current organization, INSTROL L.L.C, Doha in Qatar. We are in the Middle East, in Gulf, you may be familiar. And previously I was working with a German company, Pepler & Fuchs, those who are well known for the hazardous area interface products. So why this webinar and what we are trying to cover? I'm striving to cover the basic fundamentals of fire and gas because I was told by the faculties, your curriculum, instrumentation control engineering, a little bit touch base on the fire and gas and analytic instruments. But here I will be covering from the industrial perspective, what is the real thing followed industry. So the basics, I cannot cover the whole thing, I agree, due to the time constraint. So the fundamentals of fire and gas discipline will be covered. And I'll be bringing you the awareness in the industry, what we do in the industry in terms of fire and gas detection, what are the equipments we use, what are the standards we follow, so that you can relate to your academics, because you're seeing from the curriculum point of view, and here you can relate to the industry, what exactly is followed practically in the industry. Then third, I put discipline knowledge. It's because even though I said 40 slides, the basic can be 10 slides, but I cover more to ensure some of the faculties or the students want to enrich their knowledge or to be more expertise in this field. So I'm giving some view how we can ensure we'll be touching that areas. And finally, it's only a few minutes. I'll be addressing what all the career areas you can focus primarily under instrumentation and in fire and gas. So what are the companies or what are the types of departments you can target in your career? That is only a few minutes, but during Q&A, I'll be more willing to share my experience based on your questions. So it's my gratitude to the company whom I'm working for last 10 years. And that is a primary reason for learning some of the products and discipline and vast experience is all offered by the company. So I'm very thankful for the management. And I take only 1 minute to just briefly introduce my company, what we do. So we are a company in Qatar, established in Qatar in 2008, and we are ISO certified company. We started and we have been working with the team of instrumentation engineering professionals, and we have global presence in Qatar, UAE, India, and Europe. So what is our business? We are an oil and gas trading and technical service provider. We are primarily in trading. Trading can be defined as supply of material or services or products or instruments. So we supply fire and gas detectors, process analytics. I think you may be familiar as analytic instruments in your curriculum. Fire detection, for buildings like fire alarm panels and stuff like that. Safety primarily involves everything, starting from personal protective equipments, respiratory protection like mask, what you use now for the COVID. Similarly, we use a lot of special mask in the industry to protect us from breathing, issues with the contaminated air. And then firefighting products, obviously, when there is an issue with fire or something, we need to have firefighting products, primarily extinguishers, hydrants, deluge, and stuff like that. And we also do a little bit of industrial automation solutions like PLC, HMI, SCADA programming, or we use our resources to modify any existing logics in the plant. And at service division, we do fire and gas engineering. It means we are able to involve in the plants or client locations to engineer the solutions. Like we select what is good technology and how much is required in terms of coverage. So we do all those engineering consultancy services. Calibration is primarily very important for all the instrumentation. So we do calibration of our instruments, what we supply. Maintenance, it can be on call or annual maintenance, commissioning, support. We also do a little bit of project construction works, including installation and erection of equipments and cabling. Then finally, we are also into specialist manpower supply. Like clients need specialized engineers and technicians, we are supplying to them. So that's all about my company, and we deliver such solutions to predominantly oil and gas companies here in Qatar, like Qatar Petroleum, all the petrochemical and gas industry, like Qatar Gas. So we don't work in any other industry like cement or paper, or we don't have any industry here much, food or pharmaceutical. We are predominantly into oil and gas. So my entire session will be on oil and gas itself. Yeah. Okay, now I'll give you some idea about the agenda. So we'll start with oil and gas industry. What are the types of applications and what are the dangers and safety issues? And our job is to cover safety by our products and services. So that will give an idea. That will be only for 5 minutes. But the 30 minutes or 90% of the session is on fire and gas detection basics. So that is the one very important. And that is our primary agenda. We also touch a little bit on the latest advancements or technology in this field. And finally, I'll give you some idea, as we know from our limited knowledge, what all the areas you can master, as I already briefed you earlier. So this is our agenda. So we start with the first topic. So as an oil and gas industry, so what is oil and gas industry? Primarily, we try to produce oil, gas, or any energy products. And it can be a fuel, it can be in the multiple applications. So I classify, we have both oil and natural gas in Gulf. And in Saudi Arabia, we have a lot of oil. In Qatar, for example, we have LNG. Qatar is the second largest producer of LNG in the world. LNG, liquefied natural gas. So LNG is used in all the industry in terms of energy to to run the turbines, or to the need of energy, and also to produce power. So these are some of the applications of natural gas. So we have quite a lot of natural gas abundantly available in this area. So in industry, we have oil production and gas production, both. And we see onshore and offshore. So basically any oil and gas industry on the land, if they do any sort of processing, that is called onshore facility. And any facility like drilling wells, production wells in the sea, that we classify as offshore, because they are away from the land, they are on the water, surrounded by a lot of hazards and dangers, more safety critical plant. So onshore and offshore facilities, we service them. And I need to give an idea about upstream and downstream industry. So upstream is basically when you produce an oil. When I'm producing an oil, so basically you need to have two kind of facilities. Sorry about this. So I'm coming back to the slide once again. Yeah. So upstream is basically anything you drill. It can be inside the sea or in the land, or wherever you're trying to drill from the natural reserve and taking a product upwards vertically. So that is upstream industry. So you can see the natural gas production wells, crude oil production wells. So those are all upstream industry. Whereas downstream, basically after you get the the crude oil, for example, the crude oil is not something you can readily use it. So that you got it from the upstream facility. Now you need to process it further, like a refined petrochemical, to convert into a usable product. Then you will be downside going through a lot of processing. So that is called downstream industry. Refinery is an example of a downstream industry. And then finally, we have, I need to give an idea about this. Comes in the project business. So greenfield and brownfield. So anything you start from scratch, a new plant, just starting from the scratch, that is called greenfield. It means completely new. Whereas a brownfield or a revamp is expanding the existing facility or modifying the existing facility to meet the needs. So these are the different types of keywords we should know in oil and gas. So I just give an idea. Okay, so what are the dangers present in this industry, and why safety is so important here? See, primarily there are two important dangers, or we cannot leave that as simple. Explosion dangers. You can see a lot of times there is an upset in industry, and there is fires, and it leads to a catastrophic disaster. You can see in the first picture one of the offshore upstream industry. Basically, it's a production well, and you see there is a big fire and making the entire thing to collapse. And imagine about the people and assets. So I'm sorry to see such a situation. So we should never have it anywhere. And second is toxic dangers or toxicity. There's the second picture you can see in the slide that is taken from the recent Vaisak, incident. Probably some of you may be, read in the newspaper. The LG polymer, a plant where there is a big leak of styrene, one of the highly flammable fluid, and when it is not stored in terms of specific temperature. So in this plant, there was a catastrophic refrigeration issue. They couldn't maintain the temperature of the styrene. And finally, what happened? So it reaches the acid point or the critical point of temperature. It becomes volatile, and there was a big leak, and it affected and it killed so many people around 3-kilometer radius. So you can see not only the people working in the industry got affected, even the community and society. So environmental issues and public issues and communal issues. So this is the industry we are working, and we may be doing the business. So there are quite a lot of dangerous situations, and that's the reason in oil and gas safety is prime responsibility, starting from the top management until the bottom of the pyramid, and they cannot compromise it. So why safety is so critical? We need to protect the asset. You can see the platform burning. It's not that cheap, it's quite a lot of $1 billion, and it's nobody can just put in the water. So asset is so important. We need to protect that. And people is primarily important more than asset, because we cannot deviate out of it. And there are some reasons like insurance and government compliances. This always required to meet any industry norms. For example, you may be knowing about Sterlite, what happened. So we really need to comply in all aspects, in terms of pollution, in terms of operating procedures, in terms of government regulatory principles. So here, since we are in oil and gas industry, and primarily we are instrumentation professionals, we should cover a little bit on the explosions basics. So here, when you talk about explosion, we need to understand what is really an explosion, and how this explosion can happen. Okay, explosion is basically a combustion of a fuel, and it can be a high pressure, discharge. It's like a big gas. It's not just burning like a lamp. It's like a catastrophic, pressure discharge of fire. It will be like, the pressure is the most important thing, because if it is burning, you have time to escape. But if it is like, imagine, series of LNG or LPG cylinders or cooking gas at your home. Imagine if the gas get burned, you can see it's like a bullet. So then the same thing you relate with an industry. You have a big vessel with the gas. If it is burning, you cannot imagine that situation. It's so critical. So to start with, how an explosion can occur, we need 3 things: heat, fuel, oxygen. Heat can be energy, it can be a spark, it can be a flame, and fuel is nothing but any combustible liquid or gas. For example, petrol, diesel, crude oil, natural gas, it can be a fuel. Oxygen, you see, you relate to the oil and gas plant. Now we have this oxygen always present. Obviously in some areas they do have without oxygen, but otherwise 99% we have oxygen. Oxygen is in the air. In the air we have oxygen, carbon dioxide, nitrogen, and so many gases. So oxygen we cannot avoid, or we need it because we need to breathe it. And fuel, that is the one we are producing. We can't do much about it, and that is our primary product, or objective, processing or producing. Heat is the only thing we need to avoid. So this is the most important point here. Without sufficient heat, a fire cannot happen, and without a spark, a fire cannot initiate. So what we try in the industry, in terms of equipments, in terms of we are operating, we will try to avoid heat. Now imagine, that's the reasons, smoking is not allowed. Normal mobile phones are not allowed in the industry, because that can create this heat, and that will lead to an explosion. So we don't want that to happen. But here, another important point, not all fuel have the same compressible or flammability. For example, petrol got its own combustion index, or diesel got its own index, and gas is something different. So the flammability of each fuel is different. Some can, burn at very low temperature itself. So the heat can be so low, but still the combustion will be happening and explosion can occur. Some gas will allow you a little more, little more temperature increase. So meaning the flammability is different for different gases. So that matters while selecting your equipment or while selecting or classifying that area. How critically is that based on the nature of the gas and its flammability limits. So now we step into an excellent classic example we always use to explain this hazardous area classification in this industry. So this you can correlate to an oil and gas plant, but for easy, this is the petrol station, or petrol bank. We normally go every day to fill our car or bike. So this is an easy example to understand this critical points or how the areas are classified. Areas are classified depending upon the danger level present, and those areas the equipments has to be selected accordingly. You cannot use mobile phone in a petrol bank for this reason. Let me explain why. You can see, let me show my laser pointer here. So you can see here, this is the storage tank, which you cannot see when you go and fill your fuel. So the storage tank is always buried. So here is the actual petrol or diesel is stored. So the red one is nothing but the exact fuel in liquid form. And next there is a slight crayon color. So that is we classify as zone 0, because here the liquid, obviously we know very well it is critical and we are not touching it, but it always has the vapors. When they are filling, you see here, this is the tube getting into the, now they are unloading or loading. So there is the contact with the liquid, but more than that you can see the vapor always present. So this is the most critical or in terms of danger levels. So this is called zone 0. Then we step into here. This area is zone 1 because you are away from the tank now, but still the vapors can present when there is under normal condition. And certain things like this very light colors you keep away from here. You see here dispensers, or here for example inside your car, this is classified as zone 2, because here normally it is not a dangerous situation. Let's imagine they are leaking, when they're filling they leak it, or let's say the overflow happens, then this area also become critical. So that's why even the petrol bank, there are some shops nearby, still they don't allow smoking in that area or using mobile phones, because it's not safe. You're very close to the danger. So to make it more clear, so zone 0 is nothing but this area. Gas is present continuously. So when gas is present, it means, you imagine the previous triangle, the fuel is present, oxygen is there. So only, the heat is good enough. Heat can be a spark, or it can be a dissipation, or it can be a lighter. So whatever, so it can create an explosion. Zone 1, this areas, this is nothing but gas may exist. We may not know, but still gas exists under normal condition. Zone 2, these areas, these ones are including here. Zone 2, normally it is not present, but when unlikely any rupture or any issue, then this area also become an hazardous area. So why we are trying to learn this? Because we need to know in the oil and gas plant what are all the areas classified as hazardous and what are all the areas classified as safe area. When we say safe area, in the same petrol bank or petrol station, you get away from the petrol station. Next to that you have a shopping mall, that is safe area, because normally the petrol station cannot create such an incident, or unlikely. Compared to zone 2, it is going to be a safe area. So in the plant, you need to know what all the areas, how they are classified, and what equipments to be used. And as an instrumentation professional, we need to select instruments accordingly, and we ensure the compliance within that. And each instrument is different. For example, zone 1 equipment is much better than zone 2 certified equipment. And the zone 1 certified equipment cannot be used in zone 0. So just to give a simple idea, zone 0 equipments can be used in all the areas, because that is the most safe equipment or instrument. I hope it will be clear, because with this time constraint, I can only cover this much, but you can always reach the faculties for any further reference on the topic. And also you can utilize the Q&A session for this. So now we step into the main agenda, fire and gas detection basic. Here we are trying to cover why fire and gas detection, what we try to detect, what are the types of gases to detect, type of gas and flame detector available. Here I'm just trying to show you what are the instruments really used in the industry for gas and flame detection. And then complete fire and gas detection system and idea, because the instrument doesn't alone protect it. The instrument is only a piece of equipment in the whole loop of the system. So I want to show you in one slide the complete system. What is fire and gas detection system itself? detection. This has been already discussed in the past in the previous slide. We need to protect asset, people, and the plant itself, and the industry itself, and the neighboring community. And we also need to comply to the government regulation, both local and international standards. I'll be rushing because due to time concern, wherever it's critical to define, I'll be explaining more. So please bear with me, and you can always ask me more in the final session. So what we are trying to detect is, we are trying to detect dangerous gases and vapors, fire or explosions of flame itself. So I mean gas and flame. I also put three things. Even though I'm not covering in this presentation or webinar, we are also using like, heat detectors, smoke detectors, high pressure leak detectors. These are also important other than gas and flame. Okay. So which comes first? To my knowledge, the gas detection is the first one, then probably the heat. But again, depends on the application. The heat detector normally in the buildings, like kitchen hoods and stuff like that, where you don't know what will be the temperature increase when there is an explosion. So try to detect with a heat detector to see if there is a ramp or transient increase in the temperature around that area. And smoke is obviously just below the fire. So fire is next. Obviously, fire is already late. We got explosion for some reasons, and we need to really alert and then make action immediately to extinguish the flame or to keep the people away and keep the assets safe. Okay, so this is quite interesting. Even though we know what is gas, I want to define here what is gas. So the gas is originally, defined by the word gas, and this was invented by a Dutch chemist. I cannot tell the name due to pronunciation issues. So what he invented or what he discovered is a gas is basically a molecules, set of molecules. You can see like a carbon and hydrogen molecules. So the gas is something like moving randomly, and there is a gas leak. Imagine, so the gas is coming, physically. Some you can see, some you cannot see. You can always visualize the molecules are moving in a randomly manner, a chaotic manner. It means there is no proper structure. They'll be like, they'll be revolving around 360 degree and they're hitting each other and hit others also. I mean, I'm talking about all the gas. For example, imagine a gas coming in the ambient and it mixes with the air and it make the air pollutant. Why? Because they are able to mix in the volatility with anyone. So they are quite chaotic situation. So that's a gas. And we don't want that because it's basically it's a pollution. Okay. So what are the types of gases or its hazards? We classify into three: flammable, which is basically the gases methane, butane, propane. For your info, your cooking gas is a mix of methane, butane, propane, but it's very low concentration. You don't need to worry like what we have in the natural gas plant. But there is always a risk of fire and explosion in these gases. Okay, and all are more of hydrocarbon. And exceptional case, hydrogen is an explosive gas. Okay, for your info, there is no carbon, but hydrogen is also an explosive gas or flammable gas. And toxic, we already covered, like in the Vaisak steel, Vaisak L.G polymer issue. So styrene, carbon monoxide, hydrogen sulfide, for example, the Chernobyl issue in Japan. So all those things are related to toxicity. It can kill people, or it can make us fainted, or the skin can be damaged, or eyes can be damaged, or it can give cancer, like carcinogenic gases. So this is quite critical for people protection, and not just people. They are also, damaging the pipelines or metals or vessels by corroding, reacting with the metal. These gases are able to make, a very robust metallic structure to be brittle. So very dangerous gas. And finally, asphyxiant. I mean, this is very important because oxygen is very important for breathing. So we have oxygen gas detectors to ensure the level of oxygen present in the room or the plant is in good level, so that we have enough air to breathe. Nitrogen, carbon dioxide, because why nitrogen and carbon dioxide are also kept here is when there is a leak of nitrogen and carbon dioxide, they displaces the oxygen and the oxygen level goes low. So we are trying to target oxygen is in a good level, optimum level. For example, in the ambient or in the environment, we have 20.9% or 21%. That is quite good, but we can even last until 19 or something. It's fine, but below that we have a very serious problem. So the oxygen demand is quite high for breathing, and too much oxygen also an issue. When there is an oxygen level increasing anywhere in the room or the plant or the environment, the flammable materials, it can be paper, wood, or fuel. The flammability level increases, and you can see spontaneous fires when the oxygen level keep growing. So that is also an issue. So oxygen need to be maintained at the nominal level. Okay, here I want to touch base is very important 2 points: flammable liquid and the gas. So, for example, petrol, crude oil. I want to define two important parameters here: flash point and the ignition temperature. Flash point is related to the flammable liquid, and the ignition temperature is related to the flammable gas. Okay, so you can relate here crude oil or kerosene, for example. The flash point is at 38 degrees Celsius. Imagine a kerosene you keep in a container, you heat it to 38 degree, or your room is at 38 degree. It is not a good situation. It starts to give vapor. It will start emitting vapor, and it can be ignited by a small flame. So please be care about this flash point of different liquids, and ensure you don't reach there, so that it is still in liquid form without affecting. And this is an example, this is the reason why in LG polymer in Vizag the issue happened, because styrene flash point is reached, and then it becomes like vaporizing, and it is a danger to the entire industry, and you see how many people are killed. When it comes to the gas itself, okay, the ignition temperature plays a role, because gas is in vapor phase. So methane, for example, 595 degrees is the ignition temperature. When you have methane gas around you, and if it reaches 595 degree temperature, automatically it ignites. So this is, we call it as auto ignition. Kerosene 210 degree, bitumen 310. Bitumen is nothing but tar, we use it for the roads. So all these hydrocarbon materials got its own temperature. In gas first, it is called auto ignition temperature. In liquid, it is called flash point. What we are trying with instrumentation is, our instruments should never dissipate a heat and ensure this temperature is not hitting these points. Okay, that's very important. So now you can relate to the hazardous area and the equipments while selecting. These temperatures play a major role. The fuel, what exactly is the cause, and what is the temperatures? We always try to define that and design accordingly. Why gas detection? So gas detection is mainly used to detect gases or monitor. Normally this gas not present in that area, otherwise it is totally unsafe. So when the gas detector is installed there, normally it will show 0, but when there is a leak, it will show a reading, and the reading will be sent to a system, and an alarm will be created. It can be sounder like audio or visual alarms, so that people can leave, and also in certain cases they will take action to protect equipments in place. For example, they shut the power, they open the valve and stop the protection. So that is called executive actions or protection measures. And obviously we should have gas detector to maintain our compliance, health and safety compliances for both the people and assets. Finally, insurance is very important, because such a big investment, $1 billion worth of investments, nobody will take risk without insurance. And these insurance claims will ask for proper justification that you use gas detectors and it has been maintained properly and you have all the measures taken. So that is quite important. So you can imagine, so the industry will never compromise on gas detection. That's very critical investment for them, because it acts like an insurance compliance. Okay, so what predominantly gas or flame detector really do? They first detect, they will try to catch the toxic gas or flammable gas released or accumulations due to any unfortunate process upsets, or maintenance issues. So that is the first step: detect. And alarm is only about alerting people or the plant, like you can see in industry when there is a gas leak, you will hear announcements, then you will see the flashing lights. We call it as beacons or visual alarms, and there'll be also alert like ambulance. Similarly, we have high frequency sound signals. All these things we are doing to alert people and get them out and switch off leave the work, isolate the power and evacuate. So that's this alarm actions. Protect is, as I explained you, for example, if there is a fire and the flame detector already detected and send it back to the system, how you protect it? You activate a deluge, or a fire monitor, water monitor. So it will, spray the extinguishing agents like water or extinguishing fluids to protect the complete incident. If you cannot protect, at least, we make the entire plant up, bring it to downturn, so that you can bring it back to normal later. So it's loss, but we cannot continue, because it's going to be a catastrophic loss further. So it will be an escalation factor. We try until the end to mitigate the losses as much as possible in terms of human loss, asset loss, or safety issues. So here I want to show you the real gas detectors used in industry. What are the types? See, the first type I can show on the screen, fixed gas detectors. And I mentioned here fixed point gas detectors. Why is that? Fixed stands for permanent gas detector. It means it is installed in one location where you think gas can be present under abnormal conditions, and we select the gas detector and you wire it and you give a power, so it is continuously giving the signal what is the situation in that room. That is why it's called fixed. And why this point means it doesn't cover the entire plant or area, it only covers that particular point. Basically the gas has to, for example, I can show in the screen, has to, this is the sensor, a flammable gas sensor, and this is another sensor. So the gas has to literally naturally diffuse, and there's a leak around here. Some gas rise up, some gas sink. For example, those heavier gases, I mean the gases heavier than air, for example LNG or LPG, they will go down, and there's a leak here, it will go down. So what you need to do, you need to put the gas detector down. Whereas methane, for example, it will rise because it is lighter than air. So what exactly we are targeting here is, we position our gas detector where the gas can come. There is a leak. So the gas has to literally go inside this chamber or the sensor so that you get a reading back to the control room. So that is why it is called point gas detector. It doesn't give a coverage except that point. So your positioning is very important. So this is one of the type. Now, the next one is called open path gas detector or line of sight or beam detectors. Okay, here what we are trying to do, you can see the gas detector, it's like a two equipment in one set, like a couple. One is called transmitter, one is called receiver. So what do? You put a transmitter here and receiver here. This entire length is open, but any gas comes in this path, it is able to detect the gas, mainly clouds, big leaks. So this cannot replace this. It is both are complementing. You put surrounding with a lot of point gas detectors and use this open path gas detectors only for boundary protection, like a fence. For example, you imagine this slide is a plant. So you keep one transmitter here, one receiver here, one over here, one over here, so that you protect this entire asset. And in between, with a lot of leak sources, you can put this gas detectors. So this, the path length, it can start from 5 meters to 200 meters. So you can have such a big fence gas protection. Now, last one, you can see all those tiny ones. They call it as portable gas detectors. These small ones is mainly for personal protection. You can see the clip here. So this you can always hook it near. Some are in the belt level, some are in the collar level. So to protect your breathing zone or to protect your downside. So depending upon the gas, you can see here CO2, ammonia, H2S. So each gas detector got its own sensor. And you, so this is for personal protection. You can understand when you go in the plant when working, you have to carry this equipment with you. So this will alert you. You are in a danger zone. You can get out of the zone. And this is something you can see. There are so many gases shown here. So this is nothing but a multi-gas detector. There are so many gases. For example, you go to an area where there are not just one gas like H2S. It can be many gases. Then you carry this equipment with you. Still, it is portable. Portable and personal. Some are used for confined space monitor check. For example, before you enter that area, you want to ensure whether the gas is there or not. And obviously we don't have this permanent gas detectors enough days. So what you can do is, some devices comes with a pump and you put a hose. So what you do, you switch on this equipment and put that hose in that area before you enter. Imagine like a tank before you enter for cleaning, for example. So what do, you switch on this equipment and check whether in that area there is a gas present or not. If there is a gas present, you will get an alert so that you will not enter. So this is for, like a entry check. You can use it. And you see here, these two, quite looks nicely like a robot, and much heavier than this, because this got a battery and pump. We call it as area gas monitors. Imagine an area where 5 or 10 people are working and around, and not everybody can able to carry this gas monitors, and there is no gas monitors present, permanent one, fixed ones. So what do? You can carry this. This is a handle. You can carry this. It's something like 10 kilo to 20 kilo. You can carry this and keep it in that area, and it got the coverage, because of the pump, it got a radial coverage of 40 meters or 50 meters. So the entire area is protected, and there's a gas detector here. It will give a nice alarm, much louder than these ones, because you're trying to cover an area. This is called area gas monitor. This whole thing is temporary and personal and portable. This is the permanent and continuous monitoring. Okay, so now we step on to the individual gas detectors or individual gas detection types. So first one is combustible gas sensors or flammable gas detectors or explosive gas detectors. Here we are primarily targeting to detect a gas before it reaches the higher level so that the explosions can be stopped. So in combustible gas detector, we have two types. One is catalytic bead technology, then another one is infrared technology. So we'll step into that now. Catalytic bead, how it works basically. So you can see here, there is two beads. Basically, the bead is nothing but the platinum wire. Okay, so platinum wire wired to the electronics. The electronic is going to give a small current so that the bead is at high temperature. There will be combustion happening here inside the gas sensor itself. And so here when there is a gas leak, so the gas enters here. So some gas can cool down this bead, some gas can increase the temperature. So this will contribute a resistant change. And you know very well about Wheatstone bridge, being instrumentation professionals. So these beads are connected to the Wheatstone to arm, okay, to generate a millivolt or milliampere signal or electrical signal proportional to the gas concentration. So why this bead is, one is exposed to the gas, one is non-exposed. So this bead is used as a reference beam because if there is any issue with the ambient like humidity, temperature, and the resistance is changing, so there will be equal change. So that way we can compensate the losses due to other factors than the gas itself. So this is now the technology is quite old and it got its own limitation. Like any sticky gas coming, the bead will be coated and the bead will be dead. You cannot detect any more gas. So this is not a very reliable technology. It's old technology. We don't use it for all the flammable gas, but there is one application. Only catalytic bead should be used or can be used. No other technology available. That is for hydrogen detection. Meaning hydrogen is a flammable gas again, but not hydrocarbon. There is only H, hydrogen molecule. Now, the next one, this is the most attractive gas detector, infrared gas detector. IR stands for infrared. So the infrared gas detectors are the number one application for the flammable gas detection. So here we call it as absorption spectra. We'll not go in very detail. What we're trying to understand here is any hydrocarbon gas. Okay, here we will be careful, not hydrogen. Hydrocarbon, HC, hydrocarbon molecules, when it sees the infrared beam, infrared is one source of light and a specific wavelength in the spectra. Like UV, ultraviolet is another one, okay, visible spectrum. What we see is invisible spectrum. Now, infrared spectrum is something different away from the visible spectrum. And infrared is a light itself. You can imagine a light beam, when there is a hydrocarbon gas passing through this light, there will be an absorption. This absorption will be different for different hydrocarbons. You can see here, okay, for example, their absorption peaks are different than butane and methane. So with this, we use gas detector with specific wavelength targeting, for example, propane. Then it will be sensitive only to propane absorption curves. So the gas comes in the path, so there will be an absorption. So this absorption, we are able to catch it in the electronics and generate a signal proportional to the gas. Whatever is detected. So this is quite complex to understand, but I'll make it very simple. This is the typical, design of the infrared gas detector. To start with, there is two IR lamps, infrared lamps. We call it as sources. So the red one is the actual measuring infrared, and the yellow one is the reference. As I told you before, reference comes in all the equipments to compensate the external effects. For example, the infrared one is going out and coming back. So there is a reflector. So this is a sapphire window or a glass window. So the infrared goes here, hits the reflector, comes back. But you have to understand the whole thing is in the gas detector itself. Okay, I can show you. This is the infrared gas detector. Okay, the source is here. The infrared lamps are here. The reflector is here. So the whole thing is in one equipment. Okay, not like open path. We have two different equipments. So that's quite important just to understand. Now I'm back to the slide. Okay, see, this is the measuring infrared source, basically sent to the reflector and comes back. Whereas you see the reference source here, the yellow color, is the lamp. They send this to the reference detector and it goes to the measurement detector also, but it doesn't come out and have anything. So this is where the gas can enter. You imagine that red and black cover. When there is a gas leak, it will be coming here. All the white ones are nothing but the gas molecules, just for understanding. So if there is no gas, this detector and this detector both will be seeing the same reading because there is no absorption due to absence of gas. When there is a gas, okay, so it was expected this red beams has some absorption due to this gas molecules. So the measurement detector will see the drop in reading, whereas the reference detector will be at full signal because it is not exposed to the gas. So we compare it, and then finally we decide there is a gas leak, and we give a reading to alert people that there is a flammable gas leak, for example, methane or propane or butane. Now comes the open path gas detector. Here, okay, the same scenario, infrared absorption, nothing but you see a transmitter, receiver. These are kept apart. In the previous slide, I showed you how the whole thing is in one equipment, which is hardly 3 centimeters inside equipment or the instrument. Whereas here, as I explained before, it can be 5 meters to 200 meters, and in between nothing, absolutely nothing. So imagine there is a process equipment here, and you are living somewhere here, like an office building, and you want to protect the gas coming over there. So what do? You put a fence detector or an open path detector, transmitter receiver. So anything leaks here, okay, so you will get a reading from this receiver back to the control room to say there is a gas leak around this area, and this is quite like a compound or perimeter or boundary protection. This complements the point gas detector. But very important point to note here is the point gas detector is able to measure accurate or exact concentration, whereas these ones is more like a leak detector. It will just say, for example, if there is a gas leak here, small concentration compared to there is a big leak, okay, which is relatively smaller than that concentration, the detector cannot distinguish. So whatever it sees the absorption around this area, so it is able to give. It cannot say exactly what concentration. So this is more of a leak detector or abnormal alerting device, not like the point gas detector, which is very accurate because the point gas detector, the gas comes inside and we close the complete thing, so it is able to see the known volume of gas. But here, it's a big challenge. So it is only to alert there is a gas leak from this side to that side. So we covered the flammable gas detector. Now we step into the toxic gas detector. We'll be very quick. I already given nice examples of this LG polymer and sterlite, for example. Sterlite, it's related to sulfur dioxide issue from one of the reformers or smelters. So sulfur dioxide is one of the toxic gas. Another example, the LG polymer in Vizag plant, that is styrene, is one of the other toxic gas. So you understand what is toxic gas. But in the oil and gas industry, the most predominant toxic gas is hydrogen sulfide, H2S. We call it as sour gas, and it looks. It is sometimes smell like a rotten egg. It's a horrible smell. And when you inhale, after some time, you will also lose your respiratory and smelling knowledge. So these gases are highly poisonous, and it can be dangerous to life at even at very low concentrations. Okay, that's why immediately you inhale, you're out. Depends on the concentration in the leak. So other gases or carbon monoxide, chlorine, ammonia, some gas are smelling, some gas don't smell. That is an issue. So you cannot use your nose for detecting. It's not safe. And some gas or color, you can see literally when there is a gas leak. For example, styrene, at least you can see some white color. Some gas you cannot see at all. It is completely invisible. So odorless, colorless. So it's a very tricky, like COVID, for example, it got its own millions of forms. We never know what exactly is happening. That's why there is a big challenge. So these toxic gases are very tricky gases, and it can kill us. Okay. So the industry norms says, this is an excellent data to correlate with the sterlite issue. So when you have a toxic plant, chemical plant, a petrochemical plant, okay, you need to ensure the workers, okay, not exposed to this environment, because we know environment is polluted around the smelter. We know there is sulfur dioxide chances. So what we do, the working hours or the period need to be ensured to make sure the exposure limit is not crossing. For example, short-time exposure is nothing but 10 minutes. There is concentration, high concentration gases when there is a leaking. Over 10 minutes, what you are able to expose, or what is allowed to expose, that is called short-term exposure limits. Long-term is nothing but working shifts. What is the maximum allowable concentration in your working shift 8-hour period? For example, H2S, in industry, we are saying 5 ppm is allowed. Okay, so we have a detector alerting or alarming at 10 ppm. But the short-term exposure says 5 ppm, but still the long-term exposure says even 1 ppm, because on averaging in a day, how much you are exposed, because these gases are, some are acute, some are very severe. So even some like immediately react, some are like cancer, it start building one by one. So the issue is very critical. How we measure the toxic gas in terms of units, parts per million, ppm, milligrams per cubic meter. Let me explain what is ppm. But you have to understand, since the limits are very critical, we are trying to measure trace level. Even the minor concentrations we need to detect in terms of toxic gas. So toxic gas kills us even at low ppm. That is the issue. So what is ppm? Parts per million. There's a nice example to make it the understanding in ease. You take a room filled with balls, it can be cotton balls or anything, and out of million balls, one is red, the culprit. So that is that one particular molecule. So imagine air filled in this room and only one sulfur dioxide or H2S. Then we call that as 1 ppm, 1 part per million. That intense. Right? Imagine you're mixing a syrup in milk, for example, rose milk. So that kind of approach. So you need to go on a very trace level, because you have an exposure limits quite critical, and we want to ensure people are not breathing that much. Okay, so on the toxic gas sensor, the technology is called electrochemical. This is the only technology available currently, so it's very easy to understand. So electrochemical sensor are used for detecting the toxic gases, carbon monoxide, hydrogen sulfide, chlorine. I mean, we have around 250 gases based on the industry. Each industry got its own, gases based on the product what they're using or what they're trying to produce a product. But predominantly H2S in oil and gas industry, hydrogen sulfide. That is the most killer gas, and we target 90% H2S under the toxic category. So how an electrochemical sensor works? Again, it's I will not go much deeper. For this example, we taken the CO sensor, carbon monoxide sensor. Okay, and this is the actual sensor, which is nothing but this one. It's like a can, a small cartridge. You can always relate this to a printer cartridge. Imagine this chemical inside. Okay, so each chemical is based on the gas we are trying to detect. So to make it quicker, we have a gas leak, entering through this sensor membrane, or that is the inlet path. So we have inside electrolyte or chemical. So the chemical is different for H2S sensor, different for CO sensor, and there is a chemical reaction happening, and they will send a reference signal or electrical signal back to the transducer. I know you very well. We call it in industry, we call it as transmitter. So the electronics will be able to give a nice electrical signal. You can see the reactions happening. We'll not go in deeper on the chemistry. So here, basically the gas comes and react with the electrolyte and gives a nice reading, and which will tell us what ppm of toxic gas we detected. Here you can just relate your transducer as transmitter, and the sensor is the actual electrochemical sensor. This is the hydrocarbon or infrared gas sensor, and this is the cathode bead sensor. So this is electronics, this is a sensor. Together we call it as gas detector, transmitter plus sensor. Okay, now I'm sure I cannot cover much on the flame detector. So, but always you relate this flame detector is nothing but after gas leak, still the fire happened, and you need to have the equipment to detect the fires. So these are the applications like storage tanks, wherever you have flammable materials and there is a chance of fire hazards, then you should have a flame detector. Flame detector is targeting flame, whereas gas detector targeting gas. I mean, that's simple. These are some of the applications of the flame detector, and I don't want to go in detail. Almost all are oil and gas industry. So what are the types of flame detectors? Most of the flame detectors are optical type. Optical, when I say, again, it's like infrared, ultraviolet, infrared combination, multispectrum IR. Then we have the most latest or technologically advanced visual flame detector. So we will not cover everything because already we have time constraint. So what I'm saying, all these optical flame detectors is looking around specific radiation coming out of the fire. So for example, the UV detector will be looking at this range, then the spectra, whereas infrared will be looking at this range, and you can see each fuel will burn differently. So there is a challenge. So we need to select the flame rate accordingly to catch the fires. You see some of them are orange, some of them are blue, and some of them are glowing like this. This is depending on the fuel. And some fires are invisible. For example, methanol, hydrogen, sulfur, when it burns, you cannot even see it. So you need to select some nice UV detectors for that. And that advanced visual flame detector works in a very simple manner. It got two cameras inside. One is color camera, and one is black and white camera. So it is like a camera, CCTV camera. So it looks for the area what we want to protect and take pictures of it. And inside there is a software which will analyze. And when there is a fire, it got a nice movements, right? Dancing characteristics, and there is a flickering movement than just looking at the sun. So that way, this device is ensuring it is measuring exactly, or it is seeing exactly the flame visually and able to give a signal. Whereas the previous optical detectors or radiation detectors, UV, IR, are looking at the radiations from the fire. They don't have a camera. They cannot. And beauty of this device is when there is a detection happen, it can show the exact video, whereas those devices can only give a signal, and it is completely like blind. We can't know. We need to know in that area and check whether there's a real fire or not. Okay. So now we step into the technology advancements. I'm going to finalize in 2 minutes. I'm sorry if I exhausted some more time than what it was defined in the original slide or original start. So the first gas detector is nothing but the canaries. Canary is a bird, we use birds or animals as sentinels to see if there is any danger before we go. And this was done in the past. In the 1700s, we never had instrumentation. Instrumentation just started in 70s. Before that, we have mechanical equipments and all done manually. So this canaries, what we do, this is used in coal mines, obviously not in oil and gas. They use in coal mines. What we do, we keep this bird around us when we are working in the mines. If the bird is sick, then that's an indication that there is some gas leak, and we will not prolong further exposure. We'll just get out and ensure where is the issue, and we try to target, which is quite intensive, but that is the only way in the past. Then in 1800s, Davy or Jody lamps was launched with this one. It's very simple. We keep a vegetable oil like our kerosene lamps, and there is a wick. It burns to some level. So depending upon the oil, the flame will be of this level, and this is covered with a mist screen, meaning inside flame cannot get out because an oil and gas industry or a coal mine, so it's not allowed. So the wick or the mist screen, there is a protection screen. You cannot get the flame out, whereas air can go inside. So when there is a gas leak, the flame can go further, or the flame can go down depending upon the gas. So we have a scale to see whether we are seeing the exact flame height. So this is the way to understand there is a gas leak and how much. So very very modern and very olden technique, and obviously we have to live that time. No equipment, no instrumentation was born. Then in 70s, we have this gas detector technologies, what we discussed so far, that is a point gas detectors, toxic and flammable gas working. And in 80s, we got this line of sight open path, that also we touched a little bit. And in 2000s, last 10 years, I'm saying this is my area, we have open path laser. This is open path infrared. Now the laser came, and even we use it for H2S or toxic gas detection. We have open path gas detector for toxic also, whereas here it's only for hydrocarbon. And then we have this acoustic or ultrasonic leak detector. So we have now modern equipment with the sound wave detection. So when there is a high pressure leak from the pipelines, this detector will look for the sound wave coming out of that leak. So that way it is sure that there is a gas leak. So this worked on a sonic wave or sound wave principle. And finally, the latest wireless gas detection. These ones. This doesn't need any wiring, no power. So it can just put in any place, and it transmits signal wirelessly. And the wireless covers all gases now, hydrocarbon and toxic gas detectors, everything. Provided the wireless signal itself is industrial certified, like ISA 100, for example, it is industrially acceptable wavelengths or frequency. So now, design consideration. What we really need to look at it is where will be the gas present and how much, and where we need to position our gas detectors. So in the past we used to do in engineering manually everything. Now we have a nice 3D modeling software. So literally we can keep the plant exactly visualized, and we position the gas detectors and it will show, the green ones are like the coverage of the gas detector, whereas these ones is okay, but the red ones is not covered. So that way we have full control on what we use, whether it is covering the complete plant. So this is what I explained. This piece of gas detectors cannot do the complete job. So we need a fire and gas system or a control system. It can be PLC, it can be DCS, it can be EST. The reason for this dedicated fire and gas system is, since the discipline itself is safety issue, we will not mix the fire and gas signal with the normal process signals or factory automation signals. So these panels are called, fire and gas system or controller. So the devices will be connected to this panel, and we have a power to this panel, and this will power up the devices. We have different combinations, 2-wire, 3-wire, 4-wire equipments, and here only we have the logic. The reading comes here, and we run the program and execute based on what we have the logic, cause and effect. Finally, we alert with the sound of beacons to ensure we take the necessary actions. Some are alerting with the beacons, some may be, closing the valve and other actions. And you see here, there is also this panel sends signal to the SCADA to visualize the whole thing. Otherwise, here we only see, kind of indicators. Here we can have a nice graphics to show which area gas leak. Okay, all those things is possible, like a third-party system. And another one, like hot diagnostics, meaning the equipments also have quite intelligent diagnostic information, and that will be kept in another system. We call it as asset management system. All the diagnostics, when this equipment need maintenance, when we need to replace the sensor, when we need to calibrate, the whole thing will be stored here to ensure the scheduling is done for the preventive maintenance. Okay, this is my final slide, and I will stop here. So what are the areas we need to know under instrumentation discipline? Okay, one is automation. I'm sure everyone knows that is a very attractive discipline or a topic among the students and faculties, everyone, and this has been established for the last 15 years. So PLC, HMI, SCADAs, and DCS. Field instruments is another area. When we say field instruments, it is not fire and gas. Field instrument is basically pressure, flow, level, temperature, all the process parameters you're trying to measure in instrumentation, that is called field instruments. It's quite a nice area to cover as well, because automation is also not redundant without instrumentation, meaning instruments, the PLC, then all the systems like SCADA, all together it acts like a complete instrumentation. Fire and gas, we touched. This is quite interesting topic, and not everyone is into that. So there's a niche area, but very, very critical area. No compromise on this topic. And process analytics. Okay, this again, you're trying to measure the process gas and liquid while production process. You need to ensure there is no contamination and the condition of the gas is quite good. So we use analytic instruments for that. This is also very interesting and complex area and very nice area to touch. Control valves, obviously, functional safety, SIL or safety integrity level. This is also very important topic. When you use safety integrity or SIL validations and loop validations, what we mean here is, when you use an equipment like gas detector and the system, we need to ensure, starting from this equipment to this cabling and to the panel, the software, the whole thing is reliable, meaning it should be available all the time, because we are not just, monitoring something. We are looking for danger detection, alerting. So this is quite critical. So here comes the safety integrity. Integrity means the complete loop. We call this loop from the equipment to the panel and the alarms. So this is one loop. Okay, the whole loop we need to validate in terms of availability, and we give a score. We call it as SIL 1, SIL 2, SIL 3. SIL 3 is, for example, is the most excellent equipment with high integrity level of safety. So functionally, the instrument should be available for those applications. Okay, in some applications, not a must. Then modern computing has brought us a lot of trends in the digital instrumentation field, meaning from the same equipment or instruments, you're able to get a lot of digital data for diagnostics and asset management, like HART, Foundation Field Bus, Profibus. These are areas also you can little bit, go in the internet and find. That is quite interesting and widely used now. It's not new. It's been already implemented. So these are the topics and instrumentation I see very important. And where you can work as an instrumentation professional, obviously the oil and gas plant itself, we call it as end users or operators or oil and gas plant. And engineering companies, those who construct a plant, they are called as EPC contractors, but under them there will be engineering consultants. They are the one designing it, and obviously both the side you have instrumentation engineers requirement. And OEMs are nothing but manufacturers, original equipment manufacturers and vendors. For example, we are like vendors because we represent the manufacturers, We don't produce anything. We represent a lot of manufacturers as channel partners, and we are also one of the prospect for you to come and work. Manufacturers, obviously, those who are into PLC, field instruments, fire and gas, process analyzer, those are the manufacturers. You can always Google and find out who are all those manufacturers, or you can always reach us to help you. And finally, automation service providers. I think this topic is quite familiar. Everyone is jumping to automation. So automation service providers also an area where you can focus. With this, I close my session, and thank you for everyone for the patience. I mean, I crossed my limit in the time. I'm sorry about it because it's quite vast. I tried to cover as many as possible, and now I'm open for Q&A. I've been told the faculties will address the questions. I'm sorry about it because it's quite vast. The Q&A session. I tried to cover as many as possible, and now I'm open for Q&A. I've been told the faculties will.
I thank the presenter for this presentation. I think we have covered a lot of topic. So we have some questions available from the participants.
Yes, please go ahead.
So first question regarding the home gas leakage. So what are the basic measures?
Before we step in, there is some echo coming on. Can we do something about it? There is a technical glitch I can see. Yeah, now it's better. Can you?
Okay. The first question is, what are the basic measures to prevent gas leakage at home?
Home, okay. Okay, it's a good question because we need to see our own application before we jump to the industry. So at home, normally we have to follow the local compliance. For example, in the Gulf, each kitchen is fitted with a smoke detector, including living rooms and bedrooms. We have the smoke detectors. Okay, we never been told to install a gas detector, but there are gas detectors available. LPG gas detectors can install for additional safety and ensure precautions. In the kitchen, the cylinder fitted with proper regulator. So I want to mention a point here. There's nothing special, but why we end up in danger is we use the cheap, tubes and regulators. We don't even comply the regulations. Just need to follow the government. What is the certified regulators to be used? What is the course, and ensure the clamp and it's intact. And then for somebody really I want to have additional precautions, then I would advise you can buy a battery powered gas detector and fit on your kitchen. So when there is a gas leak, it can alert you. And this we call it as LPG gas detector. You can get in the market locally, but it's not a must. And then building approvals is mandatory. For example, here we have fire alarm in all the apartments. So when there is a fire or smoke or heat, there will be an alert. We just follow. So that should be good enough.
Okay, thank you for that answer. Next, we have a question. What are the main causes of workplace accidents and injuries, and how can it be prevented? Regarding fire accidents.
Yeah, okay. Thanks. This is also a wonderful question. I mean, the question was specific to the fire itself. So it depends on the workplace. For example, oil and gas is something, we are always working with the fire or flammable materials. So anytime, for example, if somebody not following the procedures, and then it can happen, or even though we follow procedures, Murphy's Law, anything can happen anytime because there is some challenge from the nature. Anything, equipment breakdown, for example, wear and tear of equipment, it can break down in an instant. But when you say workplace, you're off or administrative locations, rarely fire happens other than electricity. Like you have a lot of files, you have a lot of furnitures, and there is an electrical hazard. That can be the reason. Most of the electrical hazard. So our way of installing the cabling and the transformers or the power supplies and the UPS and stuff like that. Those are the prime area I feel very, very, very important. And second, we also make a very messy, we mess up the installation. A lot of cabling, like we keep repeating that. For example, in your socket, you don't load fully. You go for more sockets, and like even network cable or any cable, electrical cable, we need to have a proper again validated and certified way of installation. So electrical hazard is the most hazard I see in the normal office, non-hydrocarbon industry. When you step into the power plant, for example, then the gas hazards are there. Oil and gas, entire fuel itself. So this is what I can see is the maximum danger.
Okay, thank you for that particular answer. We have another question. it is said in the discussion that mobile in a fuel station may ignite or cause fire accidents.
Yeah.
Then vehicle engine has a spark plug. Why don't they ignite? Some question is regarding this.
No, actually, it's a good question also. We never say it will ignite. There is a chance of ignition. Okay? And in petrol station also, they told you to switch off your engine. That is a reason. And because we don't have a special engine or special electronics or mechanical equipment in the car. So if I understand your question correctly, mobile or electronics, including your engine, is a source of ignition. Okay? But normally in the petrol station, the track where you are parked to fill the fuel, it is classified as safe area or zone 2. So the best procedure is to switch off the engine before you start filling, and then move your, if it is a bike, you can move a little bit away from the sensor, and you see some people are really cautious and safety oriented people. They just, drag or just, move the bike away from the sensor and switch on the engine. So we are not saying it can happen always. It should not happen, and we don't want that. So we'll take all the precautions. Look at petrol station, what safety cautions indicated there. Obviously, what we're trying to do here is avoid ignition source close to the fuel. I hope I answered the question.
Okay, thank you for that answer. We have some questions regarding chromatographs are now available. Why are used mostly in the industry? Chromatographs.
Oh, if I understand the question rightly, chromatographs are available and why it is used or why it is not always used. I think
mostly used. It is mostly used in industry.
The chromatographs is not in fire and gas, that we have to understand. We call it as a GC, a gas chromatograph. This is used to analyze the gas composition. For example, you take a LPG gas, you cook gas, and you run through the chromatograph. That gives the exact composition. More of to check or to check contamination and to check the level of concentration. Chromatography comes under the analytic instrumentation, and still it is used. But maybe the question would be why it's not always used. For gas detection, we can't use it because the response time is too low. For gas detectors, we need the response quick because we are dealing with safety. Whereas chromatography is dealing with the process, composition, or measurement itself. And chromatographs are not always used for your info. Even analytics, we are using analyzers, laser and other optical analyzers, because chromatograph is quite complex in terms of maintenance. Okay. Probably once you step into the industry, you will understand. Maintenance also cannot be intensive because we don't have that much people, to maintain the columns, cleaning every day. We need real chromatograph technicians to. I hope this is clear.
Yes, thank you for the particular answer. So we have some questions regarding at minus degree, the stored gas properties are changed or not? The question is like this. At minus degree, the stored gas properties are changed or not?
No, what is the gas? I'm not getting the exact word. Strong?
They are given as generalized stored gases.
Stored gas. Yeah, this is also an excellent question. When we say stored gas, we normally compress and store it. For example, the natural gas. We have some cars running on gas. So if you go, and even the cooking gas itself, if compressed at specific pressure, then if you go and touch the cylinder, it will be cool because the gas compressed, a lot of pressure, and that gives the molecules are safer to some level. And this we cannot take it as granted because there are two scenarios. If it exceeds so and so temperature, it can be volatile and it can kill the problem. Like styrene, for example, in Vizag issue, as they explained. The styrene is stored and kept under pressure and temperature. When it's crossed that, it becomes so volatile and it becomes more flammable. That is one. And some gas cannot store it beyond that minus degree. That also a problem. Corrosion and the gas product characteristics will be different. You cannot burn it. No, it will be more solid. This is an excellent question because the gas hazard is related to the temperature and both. Yeah.
Okay, I think it might answer the question. You have another question. It is given as transmitter equal to sensor plus electronic module, but detector equal to what?
No, actually what I shown there, transmitter plus sensor is equal to detector. Okay, meaning The gas detector is the combination of, or the gas detector is an instrument consists of sensor, which is the basic item to detect the gas, plus the transmitter to give the signal, because the sensor cannot give the signal directly because it's a small, like a canister or a lamp. Whereas we need additional electronics to amplify the signal and then to handle all the diagnostics to send it back to your in a control room. So you relate your transmitter as a transducer. In your academic book, I think you always say transducer converts the measured signal to the usable form or a signal. So the detector is nothing but mixed of or combination of transmitter plus sensor. I hope it's clear.
Right. Another question. What is a wavelength range detected by IR detector?
Okay, so this again a good question. But you have to remember always, we don't need to memorize all the wavelengths. Every wavelength we are targeting is for specific gas. But the question to answer directly, for infrared gas detector, 3.34 micron. 3.34 micron. That is the wavelength we use for detecting the hydrocarbon gas general. But propane, for example, we go to 3.4 micron. Okay, these are the two wavelengths we use it. When you go for analysis instruments tuned to specific gas and specific concentration, you have a complete switching of the wavelengths. In gas detector, the question to be answered correctly, 3.34 micron. That's the wavelength we use it.
Okay, thank you, sir. One last question. There is a statement that inbuilt battery mobile does not create spark in fuel station. Whether it is a myth or fact?
Could you please repeat, sir, the question?
There's a general statement: inbuilt battery mobile does not create spark in the fuel station. Is that myth or a fact?
I don't agree totally, because the Tesla, the leading car manufacturer, they got their battery busted, and there was a lot of fires in their cars during testing, and you can see your mobile phone batteries become like bulging, swelling, and bust out. And so we don't have any control on any of the electronic equipment. I'm telling, we never had any robust electronic equipment to say we are safe all the time. Sorry, in safety, take all the worst case scenarios. Don't take the best case scenarios. So that's what we follow in industry. Any electronic equipment, anything can dissipate heat, anything can create spark away from the fuel. Okay, don't take it as granted. But obviously, we cannot avoid. We cannot go away from the petrol station and fill the car. So really need to take care of all the precautions and pray God that should not happen.
Right. I think that answered the question. We have another question.
Yeah, please.
Portable gas detection sensors are most be available for the employees at the abroad. Is that mandatory for each and every employee?
If I understand the question, you are saying portable gas detector used in abroad plants, not in Indian plants, right?
Available for employees at the abroad.
Okay,
Is
I
that
mean,
mandatory for each and every employee?
yes. See, people are people. Safety is common for any human. Cannot compromise. Like only foreigners who are paid well, and only the locals can be compromised. Sorry, that area permit is there. In industry, we call it as work permit procedures. When you're going to work in that particular location, what are all the safety instruments? What are the personal protective equipments? We call it a PP. For example, now the government has told you to use the mask and gloves always. It's mandatory. You cannot compromise that. Similarly, industry, a personal gas detector to be used, a portable gas monitor to be used, no compromise. Not abroad, everywhere the regulation is there. If a person die, or sorry, if there is an incident, the plant is responsible. Okay, there'll be investigations, and if they found your person is not provided with the gas detectors, then the plant will be in trouble. Okay? And that's why the protest is happening in our country. Our country is like, sorry to the politics, regulatory wise, there is some compromise, and they are not very tight following that. That's the reason we have fires. In abroad, they are following a little more better, but still globally, it is not 100%. We are trying to improve, educate every day. Yeah.
Right. Right. So next question we have: whether liquefied petroleum gas has a dust?
Sorry, sir. Repeat the question.
Whether liquefied petroleum gas has a dust?
Has
LPG. LPG, whether LPG has dust.
Dust?
Gas, inside the gas, some dust is there or not? Something.
No. Actually, to understand the question, you are trying to see there is a dust, not allowed. Okay, literally not allowed, and not only dust, any other contaminant. So this is where the chromatograph question comes back. If you measure the composition of the gas LPG, you should normally have a mix of propane, butane, methane in so and so percentage concentration. You cannot have anything else. And there is a tolerance set by the industry. Okay, so percentage of tolerance is allowed to have a little bit of contaminant, not dust itself, because dust is not good. Maybe the question is quite good. Once when sometimes it is burning, we can see a lot of instead of flame, we are getting carbon flame, black. That's because the regulator may be not clean. The stove itself is not clean, and probably it can be a bad gas. I don't know. Normally, it should not have dust.
I think it might be an answer for that particular person. And we have a last question. To become an instrumentation engineer, what are all the software tools and the hardware tools to be studied?
So if you start with as instrumentation graduate, first be clear on your subject knowledge, because I want to iterate here. There is a general blame complaint that our curriculum is not covering the industry needs. It is wrong. I can strongly tell you that 15 years back, I see my curriculum is still useful in the industry. So first be clear about your curriculum. Whatever you're studying, study with the knowledge and clarity. More, ask questions to the faculties. So you be clear in your subject knowledge. And probably you can do, like everybody is doing automation, like PLC, SCADA trainings. The trainings need to be checked, validated, because a lot of people just run for commercial reasons. They don't really teach the student. If I tell you, really speaking, you don't need to study any special software as long as you're clear about your subject knowledge. And if your college has done like INTools, MATLAB, or PLC, without investment, if you're able to utilize all the resources available and put in your CV and tell the company whom they're interviewing you, I'm very clear about what I did, and that shows that I can do anything if I'm provided the opportunity. But you have a lot of time. Let's say you're post grad and apart from university, you have a lot of time. I would suggest the automation course, and you can do INTools. For example, INTools can be used for engineering company, and also into the natural other side, like computing can be useful. But be precise. Anything you study now, if that is good enough. I'm not a fan of getting the trainings and certifications. Nobody really want it. If you're clear about your subject knowledge, industry is okay with it, because we are there to teach you once you train them.
Yes, sir. One more last question has arrived now. So regarding the workplace standards, every industry work schedule for the production worker is calculated, but for the OT workers, it is exceeding the value. Your thoughts on that?
Excellent question. That is again illegal. Whether it is OT worker or normal working hours, all need to be within the limits in terms of safety. Here we are not talking about saving money or trying to utilize the worker maximum level. But this is again on the industry. For example, if you're working in like an industry where there is no safety hazard, like gas and other exposed things, okay, so that you follow the government norms. I'm talking about the industry where there is gas exposed normally present. You cannot make a worker exposed beyond that. Overtime, normal time, all included with that. And there is a work procedure to be followed. You cannot compromise anything. But if it is a non-gas plant or non-explosion or non-hazardous plant, safety plant, it's up to the local norm and up to the employer and the employee how they are agreeing.
Okay, thank you for your presentation and the answers for the question. Now I hand over the session to Mrs. Abhimalla for the vote of thanks.
Yeah, thank you, sir. Thanks a lot, and thank you for all the students and the faculties raised this question. I hope I did something useful today. Yeah, thank you very much for all your time.
Yeah, thank you, Hari sir. First of all, I extend my most sincere thanks to the Almighty God for today's event amidst the tough times ahead. A big thank you to Mr. Satheesh Kumar, sir, for an enlightening presentation. Sir, you covered mostly on the gas detection, ensured the safety perspective, which is very much needed during this time, and also the industrial perspective. I believe all the participants would have been benefited to the session. We had also had an opportunity to share your knowledge. Thank you once again, sir. I would like to express my heartfelt thanks to our respected chairman, Dr. Babu Manoharan, Managing Director, Mrs. S. Jesse Priya, Director, Mr. B. Sashi Shekhar, our Principal, Dr. Vadi Seshagiri Rao, Dean, Dr. Pavadavadini, for giving us an opportunity to organize this webinar. A special thanks to our HOD, Dr. T. Babu, and other faculty members for their unflinching support and coordination. Last but not the least, my heartfelt thanks to all the participants for joining the session and being patient listeners. And also, they were very much interactive, and lots of questions were being answered. Thank you, sir, and thank you, participants. With this kind message, stay home, stay safe. We move to the end of today's webinar. Thank you. Thank you, one and all.
So thank you for the participation. Thank you, the presenter, for the wonderful session and the wonderful answers. Thank you all.
Thank you, sir. Thank you all.
Thank you, everyone.